Everything we know about Uranus, the seventh planet of our solar system, is attributed to the data collected by NASA's Voyager 2 spacecraft in 1986. These observations have puzzled astronomers for decades because they challenge some of the known laws of physics. But now, a recent reanalysis of Voyager 2's data suggests that the previous interpretation may have been wrong. If that is the case, these new findings will impact the upcoming planned missions to the giant planet. In this episode, we will learn about the mysterious data on Uranus and how this new study may have solved a puzzle which has baffled astronomers for around 4 decades. Let's begin. Accidentally discovered by William Herschel in the year 1781, Uranus is the first planet ever to be discovered using the telescope. Its mass is much lesser than Jupiter, but at around 14.6 times the mass of Earth, it is definitely a giant planet. Its density at 1.2 grams per centimeter cube is closer to other giant planets such as Jupiter and Saturn rather than 5.5 grams per centimeter cube for Earth. Even from ground-based observations, it was obvious that Uranus has a high albedo, that is, it reflects a lot of sunlight it receives. This is because the surface of Uranus is covered by a thick layer of clouds. These clouds makes it very difficult to identify any features on the Uranian surface which can help in estimating its rotation period. The best estimate for Uranus's rotation lies at around 17 hours and a few minutes. The rotation axis of Uranus is so inclined that its poles face the sun, causing extreme weather patterns where one pole bakes in the solar heat while the other remains cold and dark. Uranus takes 84 Earth years to complete one orbit around the sun, which means that its extreme seasons last for decades. Infrared observations suggest a surface temperature of around 58 kelvins, making Uranus a very cold place. Uranus is the third largest planet in the solar system. At 2.9 billion kilometers, that is 19 times as further away from the Sun as is Earth, it is so distant that light from the Sun takes 2 hours and 40 minutes to reach Uranus. Since it is an ice giant, Uranus does not have a real surface. That is, it is just a combination of liquids rotating together. The atmosphere of Uranus is mostly hydrogen and helium with a small amount of methane and other gases. Interestingly, the bluish-green color of the planet is due to the methane gas present in its atmosphere. When photons of sunlight fall on Uranus, methane gas absorbs the red photons, but the blue ones are reflected by its clouds, making the planet appear like a blue marble. On January 24, 1986, NASA's Voyager 2 spacecraft became the first man-made object to have reached close to Uranus, and even after all these years holds its record for the same. In case you are wondering why not its twin Voyager 1, let me tell you that's because scientists chose to let Voyager 1 explore Saturn, its rings, and in particular its moon Titan in greater detail. On the other hand, Voyager 2 continued its journey outwards from Saturn to Uranus, then Neptune, Pluto, and finally entered the outer space in August 2002, where it is still collecting data to this date and is likely to continue doing so for another couple of years or so. It's but natural to ask, how did Voyager 2 carry so much fuel which has lasted it over 48 years? Well, the answer is nothing short of fascinating. We know that the Sun accounts for almost 99% of the mass and therefore gravity of the solar system. As a consequence, when a probe such as Voyager follows a trajectory opposite to the force of gravity of the Sun tries to decelerate the spacecraft by pulling it back. However, the gravitational energy of the planets in between can be used to slingshot the spacecraft further out in the direction opposite to the Sun. In other words, the same gravity which is slowing down the planet can be used to re-accelerate it. This is possible through a technique called gravity assist. Simply speaking, the spacecraft steals some of the energy from the planet to gain acceleration, and since there is a huge difference in the mass of the spacecraft and the planet, while there is an unmeasurable tiny change in the orbital velocity of the planet, the spacecraft gains substantial amount of acceleration, which allows it to cover a larger distance in a shorter time without spending as much fuel. For instance, during its crossing of Jupiter's orbit in 1979, Voyager reduced the orbital velocity of Jupiter by 10 to the power minus 24 kilometers per second, but in turn gained a significant boost to its own momentum with an additional velocity of 10 kilometers per second. Credit is due to ingenious engineers and astronomers at NASA who not just calculated the correct angles required for this gravity-assisted maneuver of the spacecraft, but also managed to do so for all the outer planets. That's correct. Since the planets do not revolve around the Sun at the same velocity, at any given time they are misaligned with respect to each other. But every 175 years, the alignment of the planets is such that gravity can be used as an assistant in series for all the outer planets, as was the case for Voyager 2. This grand tour alignment allowed Voyager 2 to escape all the way out of the solar system into the interstellar space. Voyager 2 began observing Uranus in November 1985. At that time, Uranus had 5 known moons and a set of dark rings first observed in the year 1977 when Voyager had left Earth. Astronomers had named the moons in order of distance from the planet as Miranda, Ariel, Umbriel, Titania, and Oberon after characters in works by William Shakespeare and Alexander Pope. Uranus is tilted relative to its orbital plane by around 98 degrees, which makes it look like the planet is lying on its side. So Voyager 2's encounter with the Uranian system kind of resembled aiming at a bull's eye, with the planet at the center and its moons and rings orbiting around it. Due to this unusual orientation, the Sun always illuminates only the southern hemisphere of the planet and its moons. It was also required that Voyager 2 complete its close encounter observations in just a few hours compared with several days it had spent with Jupiter and Saturn. On December 30th, Voyager 2 discovered the first new Uranian moon, eventually named Puck, orbiting closer to Uranus than Miranda. It is indeed incredible that most of our current knowledge about Uranus and its satellites are credited to the data transmitted by Voyager 2 in a short period of 5.5 hours before it continued its journey further towards Neptune. In this limited time, Voyager 2 discovered 5 new moons and 2 new rings orbiting around Uranus, which is now known to host at least 27 satellites in total. As Voyager 2 continued to approach Uranus, it imaged the planet's large satellites passing just 29,000 kilometers from Miranda, the closest encounter Voyager 2 had made with any celestial body to that point. In all, the spacecraft returned more than 7,000 photographs revealing 11 new moons, the innermost ones being intricately involved with the ring system, and 2 new rings orbiting the planet, and of course, a wealth of information for astronomers to analyze for decades to come. But it is not all rosy with this strange planet lying on its side and rotating in the opposite direction from east to west, just like Venus. Amongst others, Voyager 2 also studied Uranus's magnetosphere, that is, the space around the planet where its magnetic field is noticeable. Voyager 2 revealed that Uranus's magnetic field dipole was tilted by 59 degrees compared to its rotational axis and offset from the planet's center by about 1/3 of the planet's radius. But the strangest thing it discovered was that while the magnetic field lines were laced with electrons, the magnetosphere was largely devoid of plasma. This was weird, and for decades scientists have been trying to find a valid source of the charged particles found along the field lines. One of the popular explanations for these data came in March 2020 when a group of scientists at NASA's Goddard Space Flight Center in Maryland published a reanalysis of data from the Voyager 2 Uranus flyby, they found that a giant magnetic bubble known as a plasmoid may have been slowly whisking the planet's atmosphere out to the space. But an even better explanation is presented in a recent study published in Nature Astronomy in January of 2025. A group of astronomers led by Dr. Jamie Jasinski of the California Institute of Technology reanalyzed the Voyager 2 flyby data of Uranus from 1986 along with the data of Sun from the same time period. The study finds clear indication that just before Voyager 2 encountered Uranus, it was hit by a huge sunstorm. The study therefore suggests an alternate explanation for the anomalous data from Uranus. It is possible that interaction with the solar storm carried away the plasma in the Uranian atmosphere, leaving it empty for a short duration while Voyager 2 was collecting its data. If true, this study has strong implications for the future missions planned to Uranus. At the top of the list amongst the upcoming planned missions is NASA's Uranus Orbiter and Probe, which will closely observe Uranus, its rings and satellites to unravel some of the mysteries surrounding the blue planet. Last year, NASA also announced that the New Horizons spacecraft will observe Uranus and Neptune from its position in the outer solar system. Amongst others, China intends to have Tianwen-4 fly by Uranus by 2045. This mission is planned to fly in the year 2029. However, the recent study has provided food for thought to planetary scientists as well as engineers involved in strategizing the Uranian missions. Even if the results are correct, there is no guarantee that the newer missions will not encounter a similar situation because Uranus is under the influence of solar activity for a significant 5% of the time in its orbit. Moreover, the NASA mission is constrained by time, because scientists want it to fly soon so that it can reach Uranus by 2050 at the time of Uranian equinox. As mentioned earlier, Voyager 2 could observe only the southern hemisphere of the Uranus and its moons during its encounter in 1989, but astronomers now hope to look at the dark side through a mission which, if on time, will provide a view of the entire system illuminated by sunlight. This is worrisome because if the chance is missed, it will reoccur in 2091. Rest assured, next few decades look promising for filling in the gaps of our understanding about this intriguing seventh planet. I hope you enjoyed this little summary of what we know about Uranus. Please do share your feedback with us in the comment section below, and if you find our content useful, please do subscribe to our channel and share our videos with other astronomy enthusiasts. I will see you next week. Until then, take care.